So now we're doing FreeCodeCamp Legacy Python for everybody, representing relationships in a relational database. All right, so let's go. Actually, make sure we have our notes out to start with, which we do right here, and let's go.
Now we're going to represent these relationships in the database.
Okay, that's excellent. I was looking forward to this from yesterday. So let's scroll it all the way down over here. Let's go up here and grab this date, drop it down here. Little Control V action. Change this 7 to an 8. All right, and so we're good to go on that. So let's get to it. Representing relationships in a database. Representing relationships in a database. All right, so let's see what's going on.
And again, what we're trying to...
Okay, before he gets into that, let's write this down. All right. All right, so I guess this is the new way. Representing relationships in a database normalization 3 in F. What is that? Database normalization 3 in F. Okay. There are tons of database theories. There is tons of database theory. There is tons. Okay, we're going to change that one. There are tons of database theories. Way too many to understand without excessive predicate calculus. I learned calculus, but there must be excessive to get that theory. So let's go. Do not replicate data. Makes sense. Reference data. Point at data. I don't know what that means. Use integers for keys and for references. Okay. Add a special key. Column to each table which we will make references to. By convention, many programmers call this column ID. Okay. Interesting.
Solve here is this notion of database relationships in the database. And again, what we're trying to solve here is this notion of database normalization.
Why does he look so scared is the question. What is this? What's the fear? Does he not understand this stuff a lot? Is he like Mr. Python and databases aren't his deal, but he's got to do it anyway? I don't know. Let's go.
Third normal form. There is so much theory, right? But in this lecture, I'm just going to condense this down to don't replicate string data and use what are called keys. Use integer keys to point at those things. And we're going to use these integers then to point. So assign each row an integer, and then we're going to point from one row to another using those integers. And so we're going to add these special key columns to each of the tables, and help in the database will even give us help managing those. Now, and so we still need to keep track of, who.
Okay, what? We want to keep track of which band is the creator of each music track. What album does this song belong to? All right, we're not going to write this down because we haven't been writing it down. Let's go.
Who is the creator of the album? Which album a track belongs to? We've got to create these relationships, and we have to come up with ways to store those relationships. And so the idea...
Okay, what are we looking at? Integer reference pattern. Use integers to reference rows in another table. Okay, let's write that down. Where you at? There we go. Integer reference pattern. All right, integer reference. Oops. Reference pattern. Okay. So we use integers to reference rows in another table. Okay. Let's go.
Is we're going to have a column in a table, which is the key column, and we're going to call this the ID column. And so this is a row. It might have many bits of data here, but in this case, it's just the name of an artist. So this album is going to belong to an artist. And we're going to assign a number inside the database, and so that Led Zeppelin is 1 and AC/DC is 2. And so we have this key. This is called a primary key. And then later, when we want to say that the Who Made Who album really was done by AC/DC, we put the number 2 in. And so the difference here is, instead of saying AC/DC in this record, we just put the number 2 once we've established this number. So we assign keys, and then we have these pointers that point back. And so that's how we model a relationship with these small integer numbers.
Okay, that kind of makes sense. So yeah, that way we don't have to type out AC/DC. We just type in, I guess, artist ID. We know this is artist. Here's ID. And so 2 is going to be AC/DC. 1 is going to be Led Zeppelin. Led Zeppelin made 4. And AC/DC made Who Made Who. Okay.
And so there are 3 basic kind of keys.
All right. Here we go. Let's write this down. What are 3 kinds of keys? 3 kinds of keys. All right, we've got a primary key. Whoops. Primary key. Generally an integer auto increment field. Okay. We'll see what that means. Logical key. Okay. What the outside world uses for lookup. Okay. And then we got a foreign key, which is generally an integer key pointing to a row in another table. Okay. Okay. Let's go.
That we use. 1 is the primary key, and that is that little ID column that is just a number. But once we give Led Zeppelin the number 1, Led Zeppelin is the number, has got the key 1 for the rest of that database. The logical key is the text area that we use that you might look up. So the title of the band or the title of the album, that's the logical key. And then the foreign key is one of these keys that is really pointing to the primary key of another row. So that's called a foreign key. And it's key.
Back up. All right. So ID would be the 1. Like, let's say we were looking at that thing over here. So this is the primary key. The title, this is the logical key. All right. And then the foreign key are these. What? What? Generally, an integer auto-incremented field is the primary key. Which one's the primary key over here, though? This one, 1. Okay, I guess that's 1. And then this is the foreign key is this one. These are the foreign keys. This is the primary key, the foreign key, and this is the logical key. Okay, that's what it's got to be. All right, so let's go. Let's write this down before we get to it also. All right, here we go. Key rules. Key rules. All right. So, best practices. Key rules, best practices. Let's do this. Key rules, best practices. Okay. Never use logical keys as the primary key. Okay. Oh, yeah. Which one was the primary key? That's the ID. Yeah, never used that. Logical keys can and do change, albeit slowly. Okay, I guess that means we could put like, if like Led Zeppelin is 1, we can change Led Zeppelin to be who was another band from the old days? Aerosmith is now 1 because we changed it, right? But 1 is still there, but now 1 equals what would we say? Aerosmith. There we go. So there's that. Let's go to the next one. Relationships that are based on matching string fields are less efficient than integers. Okay, so matching string fields are less efficient than integers. I believe it. User ID log word. What is this? All right, we'll keep going.
You might think that you want a foreign key. And you might think that you want to use something like an email address as the primary key for a user table or something like that. The logical key should always be separate, and there should always be a primary key, that integer number. Because things like logical keys do change. People do get new email addresses, and if you've got that email address as a foreign key pointing all over the place, it doesn't work out so well.
That would be real bad.
So that's why you use these small integer numbers that have no meaning outside. So sometimes if you're on a system and you see a URL and you see some number like 422,016, you're like, oh, that turns out to probably be my primary key in their database. So sometimes you can look in a URL and you can see these primary keys in the URL, but they don't mean anything outside of that particular system.
True.
So like I said.
All right, so let's do this next one, foreign keys. Foreign keys. A foreign key is when a table has a column that contains a key which points to the primary key of another table. Okay. When all primary keys are integers, then all foreign keys are integers. This is good. Okay, we don't need to know any opinions. All right, there we go. All right, so what's going on here? So this is the foreign key. Artist ID. What is this?
I said a foreign key is a key that is really pointing at a row in a different table. And so we have the album has a primary key for it, but the artist underscore ID points to a row in the artist table, as we will soon see. I have a naming convention, and in my naming convention on this lecture, I use ID for the primary key, and then artist underscore ID, I use uppercase for the table names. And then artist underscore ID says this is a key. This is just a key that points to the ID key of the artist table. And so that's what I do. So you'll see in all my stuff I'll use that. It's a convention. It's not something SQL forces you to do. But you will find when you go to organizations and work on their databases, these conventions are very important so I can do something and you can understand the rules in which I created it. Some of these, you'll find this used by some people. You'll find completely different conventions, and that'll be okay. Whatever convention your organization uses, learn that convention. So now we're going to talk about how we put these keys in, and then how we actually make the connections from one row to another row.
Yeah, okay, that sounds good because I am literally so confused right now. Especially with this part right here. I mean, I get it, but I don't get it. But he just said how we're going to do it, and we need to figure out how we know artist ID over here equals this ID over here. So mystery, but he just told us in the next one we're going to learn that. So that's pretty important. That being said, let's read this. Question, what is a foreign key? A key that's not supposed to be there? Of course not. A key that uses non-Latin characters? I mean, no. A number that points to the primary key of an associated row in a different table. That sounds a lot better. A key that the real world might use to look up a row. I think that that's logical key. I think we could do this one. Check the answer. Looks good. And submit it. 89%. Look at us just flying. And submit it. All right. So that's that. Now we're on to relational databases, relationship building. And we'll see you next time.